Good evening, everybody. Today we intend to discuss on titanium bearing SS grades and its qualitative issues by Amit Mukhopadhyay. It's usually experienced that the titanium bearing stainless steel grades like 316Ti, 321, 321H always face the problems in the subsurface of the billet or blooms. The subsurface of the macro sample found either pinholes or blowholes like appearances. These are neither pinholes nor blowholes. These are carbide nitride inclusions, titanium oxynitride, titanium carbonitride. Inclusion generation is inevitable, but the deadly effect can be optimized during hot working. Scrap. Kindly remember that a selection of good scrap with an intention of low percentage of sulfur and percentage of Haas opening. The reason is we need to target a low percentage of sulfur opening, like less than 0.030, so that after proper desulfurization, sulfur less than 0.002, the steel physical behavior would be favorable in terms of proper castability, followed by LNC and TNC can be overcome. Induction furnace or EAF, fluxes and ferroalloys to be selected in careful manner so that unwanted elements concentration must not be increased. AOD. Titanium bearing grades, the maximum attention is required in AOD and CCM. In AOD, a reasonable quality of fluxes for a favorable basicity is required. Apart from the basicity, the viscosity of the slag is also highly recommended. It's experienced that a lime silica ratio with 1.7 at 1680 degrees C usually can have a good conductivity to capture inclusions. If the temperature would be high, then this ratio would be desired at the level of 1.8 and more. But the slag should be free flowing and enough compatibility should be there to address the inclusions. After the final slag off, a minimum quantity of slag will be remain in the vessel. It's advisable to put ferroaluminium rather than calcium alloys. With a recovery of more than 60% of aluminium is considered to be a good recovery. A good recovery of aluminium is required to obtain a good titanium recovery. It's highly recommended to get the following: sulfur less than equal to 0.002, oxygen potential less than equal to 30 ppm, recovery of aluminium greater than equal to 60%, percentage of aluminium in the bath 0.035 to 0.045. These values are considered to be a favorable ambience for better titanium recovery. Recovery of titanium greater than equal to 75% to 85% are a good condition to optimize titanium inclusions. If the titanium recovery would be less, it signifies that titanium oxidized extensively and there would be higher possibilities of inclusions and its deadly effect. So in AOD, let's take the following steps so that casting followed by hot working would be smooth and or seamless. Reduction slag. Good basicity, good viscosity with compatibility. Recovery of aluminium more than equal to 60% prior to get that sulfur less than equal to 0.002 should be achieved. Recovery of titanium 75 to 85%. Calcium silicide wear in a view to have nearly 20 ppm in the final report. CCM. To avoid cracks inclusions in the post-rolling stage, the important areas to concentrate is CCM. Tundish and its overall characteristics. Tundish can be hot or cold. There are enough possibilities that nitrate, carbonate, sulfate can be mixed with gunning mix or the refractory. It's observed that hot tundish percentage of MgO 65 to 70% but having carbonate, nitrate, sulfate are having increased level of pinholes, blowholes in the billet macros. Percentage of MgO 65 to 70% but no carbonate, nitrate, sulfate, less percentage of pinholes, blowholes. The tundish with bigger volume can be fitted with dams and wears, and a trend of improvement is experienced. Again, in smaller tundish, there is not enough space for dams and wears. Their increased length of ladle shroud along with monobox, refractory made box which can control the initial turbulence of the metal stream, experience less susceptibility of the inclusion train. Monobox, increased length of ladle shroud, argon shroud gum. Besides of these physical cares, during casting, casting powder can also be explored whether any compound's presence can be favorable in inclusion's formation. Irrespective of the billet size or controlled super rate, 35 degrees C to 45 degrees C with systematic casting speed will be helpful. New ladle must be avoided well-soaked and preheated ladle in circulation. Typical plate bore can be 5 mm plus size than the regular plate bore. Ladle bottom should be air cleaned and there should not be any ladle addition. Billet inspection. It's an important precaution to obtain better quality product. The surface defects like joints, scabs, slag patches, and non-metallic entrapment should be taken with high importance and should be ground to remove. Grinding is a metallurgical action. The preferred grinding should be auto grinder to avoid uneven surfaces in post-grinding stages. Rhombodity should be a valid checkpoint. After benzo cut billets, the core of the billets should be inspected each and every pieces, especially for subsurface defects like pinholes and blowholes appearances. Actually, these are neither pinholes nor blowholes. These are the outbursts of the gaseous inclusions. These defects originate from SMS and as previously discussed, these appearances can be optimized by taking calculated steps. My suggestion is when pinholes or blowholes are observed, then either it's advisable to take for RCS and then for round rolling. Special precautions can be taken for the central cavity if high. Both the ends of the billets can be welded to prevent further reoxidation in reheating. Preheating and soaking. There should be a stage of final inspection according to the severity of the pinholes or blowholes. The preheating and soaking temperature can be predetermined. The hot rolling is a process to make the material malleable, but too high temperature in the soaking zone is not at all advisable. The weakest area of the billet or bloom are the corners. High temperature would lead to deformation with cracks on round or RCS, because again, the inclusions in high temperature presence can come out in the same fashion like it comes out in the billet or bloom. What should be the rolling temperature? It's a long discussion, usually differs mill to mill and furnace to furnace. My recommendations are recuperator and oxygen potentiometers to measure in percentage or ppm in the furnace would be highly beneficial. The titanium bearing grades are not alike of the common grades like 304L, 316L, 303 because of the existence of inclusions which are indispensable, but upon heating the inclusions can come out in the form of cracks. So, in conclusion, try to understand the nature of the defect first, then extrapolate the defect to its origin. And for a quality rolled product, we need to start from scrap. Be careful to your steel, steel will be careful to you. Thank you very much for your time and patience to listen. If you have any question, kindly ask in comment section.